Now, I'll mention that we didn't get to talk about as many things and get into everything that I would like to have gotten into because we wasted almost half the class just drawing this graph and this graph, okay? This graph should have been down in a minute or two at the most. 10 minutes later, not everybody had this graph. Everybody has to be able to get these graphs quickly or we can't talk about what we need to talk about because the graphs give us the context for the things that we need to be looking at. Now, we were asked to find the average rate of change on the interval from x equals -2 to x equals -1. And I reminded people that the average rate of change between two graph points is the slope of the segment, which is equal to the slope of the fundamental triangle between the two graph points. And this is just a reminder, it's not a complete statement, but reminding you of what we talked about previously so we can see how we're doing with that. In order to do this, we want to do this in reference to this graph that we've constructed. Okay, now not everybody was doing it in reference to this graph, which made it difficult to locate the points and so forth, but most people kind of had that down. So you want to be careful about that. You have to be able to construct this graph. I can't emphasize that enough. Quickly and accurately, and you have to know in advance pretty much what it's going to look like. Okay, so between the x equals -2 and x equals -1 points, we're going to construct a fundamental triangle, and the slope will be our average rate of change of y with respect to x for this interval of the x-axis. Now you notice I've sketched this interval of the x-axis from x equals -2 to -1. I didn't indicate whether it's a closed or an open interval. It really doesn't matter, but usually we regard it as a closed interval. Okay, well, the corresponding points on the graph for x equals -2, the point is -2, -8, as we can confirm if we just look back at the table. And for x equals -1, the point is -1, -1. Also easily obtained from the table, but we shouldn't have to look at the table now to know what the coordinates of these 2 points are. And in fact, if we graphed the thing, we might well have labeled those points in the first place. Then you draw a fundamental triangle. Now the question came up, do you draw the fundamental triangle on this side or on this side? There are 2 ways to draw it. And the answer is it doesn't make a bit of difference. I would say wherever it's going to be easier to label. Okay, so I drew it on this side just to illustrate, because a lot of people drew it on this side, that you can draw it this way. Then we calculate the slope of this fundamental triangle. Fundamental triangle, this point to this point, sides parallel to the coordinate axes. There are only 2 ways to draw it. Either way is fine. Okay, on this drawing, I labeled it the rise from this point to this point. Well, we can calculate that rise. Okay, we just do -1, the y coordinate here, minus -8. -1 minus -8 is 7. Now, people are having still a little bit of trouble with the idea of why you subtract this one from this one if you're going from here to here. And I'm going to tell you should do this with all the graphs that you work on for the next little while, when the numbers are like single-digit numbers, things that you can count on your fingers. From -8 to -1, we're going, the rise is how far we go from here up to here. We're at y equals -8 here. Okay, this point projects over to -8 on the y-axis. This point projects over to -1. To get from -8 to -1, we start at -8 and we go to -1, -7, -6, -5, -4, -3, -2, -1. How many is that? That's 7. We had to go 7 units to get from -8 to -1, and that's identical to the difference. -1 minus -8 is 7. This calculation, if done right, will always give you the number of fingers that it takes to get from one point to the next. And of course you have to understand that in terms of integer points and small integers so you don't run out of fingers. So that when you have to go from -7.382 up to positive 325.931, you don't have to try to count that on your fingers. You just subtract the first one from the last. Simple. And of course it's valid to use a calculator to do that subtraction. Here it's not valid to even think about a calculator. Okay. Okay, well anyhow, that's the rise. There's your rise, 7. The run, well, you're going from -2 to 1. Now the calculation is -1 minus -2. Now we know that's 1 unit, and -1 minus -2 gives us -1 plus 2, which is 1. We have to understand that arithmetic in terms of a number line. Okay, we have to understand in terms of just counting along a number line with our fingers what these calculations mean. So we'll know what they mean when we get things that we can't count on our fingers. Okay, so anyhow, that's the rise and the run. And you would get the same thing if you draw the triangle here. The run from here to here is still 1. The rise from here to here is still 7. And the calculations are identical, it's just that we label them on this triangle instead of this triangle. The slope is just the rise over the run. Either triangle, it's 7 over 1, which is 7. So the rate of change on -2, -1, the x interval -2 to -1, is 7, the average rate of change. Okay, so that's very clear. Okay, now the next thing we want to do is we want to do a fundamental triangle. Well, we want to calculate an average rate of change between x equals 1 and x equals 3/2. And we are going to run into the problem that, well, we haven't evaluated this function at x equals 3/2. We don't know what the coordinates at that point are. Fortunately, we can easily find it, and before we even calculate it, we're going to draw it on our graph.